Hi, my name is Jeremy Gitzet, and I'm from Capital One. I'm a machine learning engineer and a developer on the open source repo, the Data Profiler. It's come from Capital One. I'm going to discuss data profiles and how we can use them to enhance our machine learning processes. Whether it's manually curating information using a library to inspect data sets or gathering summaries and statistics on data sets, data profiling is essentially the process of examining the data available from an existing information source and collecting the statistics or informative summaries on those data sets. So whether that's numerical statistics or just metadata information about those data sets, curating that into a profile. And if we're going to focus on being data-centric, obviously we need to understand our data and use that understanding to be able to enhance and manipulate our data. So utilizing data profiles can give us introspection into those data sets, or give us that insight into those data sets quickly and allowing us perhaps do things more efficiently. So whether that's understanding the types of labels that exist in a data set or potentially labels that are missing within a data set, understanding how to augment that data, like I said, missing data, or potentially finding avenues in which we can augment it in terms of like adding noise to data sets or finding ways we can transform these data sets to supplement our original information. And profiles can give us an idea of what is there and what's missing. We can use profiles to audit our data as well. As well as for model explainability, we can utilize data sets to understand what types of data sets allow our models to perform better. And so having that metadata, curating those data sets, and associating that with our model accuracies can allow us to make those predictions. And it can all allow us to get access to data more quickly, data behind secure environments, giving insights into those data sets. We can potentially transport those profiles around, or there are other mechanisms which I'll discuss in this presentation that we can utilize profiles to be able to get developers or model developers or data scientists access to that data to understand their data sets more quickly and utilize them more effectively. And obviously, this is just a subset of potential ways you can utilize data profiles. The list goes on. But a single profile or a single understanding within a single data set only gives a snapshot for that one single moment. So obviously data changes, it's dynamic. And whether it's changing because it's coming in over a stream, or if you think about it in terms of labeling a data set, you might have two different people labeling the same data set, and they come up with differences in what they're identifying within that data set. Data profiles generates that metadata around that data set. It allows us to gain insight on what specific characteristics of that data set might cause those changes in identification, or within a stream, what is changing within that data that could be causing, for instance, data quality checks to fail. We could also look at it in terms of, if we had a data set that performed well, and we can then compare it against something historical that, that didn't perform well, we can start to understand what it was in this new data set, perhaps, that we might need to augment or change in future data sets that might have that missing to supplement that data to improve our models. And data profiles helps us simplify these processes, helps us understand what's in our data sets more quickly, and allow us to iterate faster to getting to these solutions. So obviously we want to have these snapshots at a single point in time, but we also want to be able to, have data profiles in such a way that we can compare historically. So that's really important. And just to give an example, these are some of the examples we have within our open source repo, but an idea, and this is only a subset, of course, of profiles that can exist. You can have structured profiles, and what does structured data look like? You can have your overall, cross column or cross dictionary or entry specific piece of information. You can have within columns of a data set if it's tabular. You can look at within that column, what is what do those specific statistics look like means, mins, maxes. You could look at the different categories that exist. So it's a plethora of information that can exist. Structured, you can look at, data labeling, like what words exist, vocab, you could look at n-grams. And then of course, graphs, subset, they're looking at the connectivity distribution of edge values. Like I said, this is just a subset of ideas that could exist for data profiles. And obviously it's quite expansive, and we can go past this into other types of data sets as well. It's not limited just here. But this abbreviated list gives us a little bit of insight of, the types of things that we could be tracking and how we can make these comparable. And I'm not going to spend long on this slide. It will reappear later. But data profiling should be easy. Like I said, if we want to simplify these processes and automate these processes, we need to make it so simple, it'd be foolish not to do it, essentially. And we need to standardize these processes so that way we can build upon our ML together. Like I said before, data is dynamic. So making these profiles in such a way that they can be dynamic is really important, updating and merging. And so this is kind of a snapshot of what it looks like to do it within our own repo. But there's different types of data profile repos that do exist besides ours. And so ultimately, we need these profiles to universalize utilizing data profiles themselves. So that way we can enhance our ML. And I'm going to go into that next, essentially. And of course, we've just been trying to understand data profiles right now and what those mean. And so now I'm going to go into how we can use them within our workflow. And so we can look at it in terms of like utilizing the data schema that we get out from the data profile and where that applies. Obviously, anomaly detection as a mechanism similar to like data quality checks. Or data drift or data quality checks. We can utilize it for synthetic data and understanding synthetic data or creating more of this augmentation, and then even data labeling and how we can utilize that. In terms of like data schemas and summaries, obviously modeling is an important part of our is why we're utilizing data to begin with. Being able to understand the data helps us understand the differences between data sets. So as an example, like I said before, comparing one data set's profile to another helps us understand why one model might be performing differently than another. Or, like I said, identifying gaps in our data. What might be missing within one data set to another for models is really important. And so we have to, obviously know our data to be able to assist in designing ways we can make these data sets better. We can use it also to, like, for instance, a modeler looking at the differences between their training and validation results. You can look at the difference between your training and validation profiles to identify gaps in in the data set populations between the two. And again, how can we automate this so that way we can augment our data to help assist in filling in those missing gaps? And so the other way to look at this as well is if we have data profiles and we have models, and I'll get into this again later, can that help us design our model architecture? Could we be using information, the metadata around these data sets to design our model architecture, not design our model architecture and then feed in the data? So that's one mechanism to look at that. And then if we look kind of a little bit into more detail, is you can utilize this while not programmatic. These profiles can help generate, human digestible results. So from a profile, generating these reports, whether they're graphs or PDFs or whatever it might be, being able to explain what's happening in these data sets is really important for the person developing these models. And this is just, some simple examples. Obviously, understanding, null value correlations or where null values might be missing, or the distribution within a data set to explain why one data set might be performing differently, like simple ideas here, obviously. Obviously, data summaries can also be used for schema validation, right? So whether it's utilizing it for helping develop your models, but we can also utilize it in the same vein for schema validation. So looking at a data set, trying to make sure that the next data set coming in, whether it's part of a pipeline or you pull a data set and profile it to compare, making sure that we have consistency in our data sets. So building these profiles to enhance our pipeline development and ensure that anything new coming in might be following those same guidelines. And one way that we've been working on this in the open source is integrating into other packages. For instance, Great Expectations is a great library, which does essentially this sort of auditing of data sets, right? We want to automate these processes for auditing our data sets, a data set into Great Expectations. It will apply what you expect that data set to have, and utilizing profiles or utilizing profilers themselves to be able to automate these processes or to build these expectations or give guidance into building these expectations helps us build these pipelines essentially. And this is just, of course, an example of what that looks like. And so in this case, we're validating that a data set's labels during profiling is expected to meet a specific confidence threshold. Pretty straightforward. You obviously feed in a data set into this expectation. It's going to go through a labeling process, which labeling I didn't really mention or discuss too much before is another component of profiling, essentially. Being able to identify within the data set what types of labels might exist, whether that's columnar or, like I said, in unstructured with labels within a piece of text. This expectation is trying to make it simple, where you want to make sure that, when it's identifying these labels, it's the confidence that labeler has is within the expected tolerance, of course. So previously in the schema detection, we looked at auditing our data to make sure our pipeline was validated. This is very, anomaly detection and drift detection is similar in the sense that we can utilize these checks and alerts to trigger refit for our models. Our data is constantly changing. It's dynamic. So if we can understand the bounds of our model with respect to data profiles, we can create alerts for when new data is no longer within these expected constraints. Even if we don't know the bounds, we can also utilize the profiles of what we used to train the model with to create these expectations. So, as data is changing, profiles can then be utilized to trigger these alerts. And we can, or to at least give guidance of where we need alerts within our pipelines to trigger these sort of events. And as moreover on this topic of data being dynamic, we need to be able to track these profiles over time. So if we looked at, drift analysis or time series analysis, being able to track the history of profiles as time changing. So making adjustments, of course, for, as data drifts, there might be some acceptance in what that looks like. So building these changes, identifying these gaps in times gaps over time, or utilizing this potentially, like I said, for anomaly detection, being able to combine a historical set of profiles to make these identifications or these triggers. Of course, synthetic data is another important aspect of data profiles, because if we understand our data, can we not just generate data from these profiles? And if that's what data profiles are supposed to do, give us those insights. And this last part is really powerful because it can also speed access to data. And I'll talk about that in a moment. But getting access to data allows us to speed up development, and allows us to generate models or iterate faster. And so obviously, anything with data security is paramount, which means that depending on the sensitivity of a data set, it can't leave a secure environment. But a data profile, which is only a description and not the actual data itself, may be able to leave the profile depending on what's in that profile. And so what you can think about doing is generating these profiles within secure environments and either passing the profile itself outside of it. So that way you can give introspection to that data set without having access into that secure environment. Or you can generate synthetic data off of those profiles. And so this generalization of this data set allows us to have access more quickly. In addition, we more recently were working with YData about utilizing data profiles to be able to do comparisons between synthetic data sets. So you can look at it from the sense of, maybe you have a data set within a secure environment, and you're generating these profiles off this data, within the secure environment. And then you're generating synthetic data either off of the data itself directly or from a profile. And then you can generate you can either you can utilize profiles to ensure that your generated data sets are comparable or that they reflect what you would expect, right? So this goes back kind of like to model development, like what does this data look like? And what does the new synthetic data look like in respect to the real data set? And so before you pass these out of the secure environment, you could utilize that for evaluating to make sure both that the data is representative, but also secure, right? To make sure there's nothing in that data set that we could be leaking, which kind of segues into the next part, which is the last use case we'll discuss, utilizing these data profiles to ensure the security of a given data set. So I touched on this before, which is a subcomponent of profiles are data labels, being able to identify not only the statistics of what's within a data set, but what that data set represents. We can think about it like in structured data, what a column might represent, or in unstructured data, what a specific word or phrase might represent. So that could be like in column or data sets, like a person's name. It could be just a security number, utilizing labels to be able to identify this and secure a data set, which is really important because then we could utilize profiles to identify where sensitive data might exist, or utilize profiles to ensure that before data leaves an environment that it doesn't have sensitive data, and be able to identify where within that data set we can then scrub them before it leaves that environment. So we're protecting our data at rest as well as prior to flight before it moves into a new environment. Naturally, the next progression of data profiles, and I've tried to touch on this multiple times already, which is automating these use cases. And so we talked about before where data profiles can help us design our own validation checks. We can take these profiles to look at different aspects of it. For instance, what are the distribution of values within it, min, max value within a data set, expected categories. You could look at order, like within structured data, is this data set ascending, descending, random? There's a plethora of different quality checks you can apply to a data set. But with data profiles, why not utilize these profiles to automatically build these checks for us? Identify these gaps automatically. And instead of just utilizing it as guidance, we can utilize these profiles to build these pipelines for us. And that allows us to be adaptable, right? Allows us to adapt to future data sets and it allow us, again, to iterate faster. If we think back to when we mentioned like tracking data profiles, we can associate profiles with previous checks that humans decided to employ for these data sets. So the metadata around why we're using these profiles associated with the profiles itself to help us automate these processes of building it, of accomplishing the tasks that, that's what's really going to unleash the full power of data profiles. And we can do that similar idea, not just automating pipeline validation, but we can look at it in terms of automating feature selection. When we chose specific features or the ways we, did different data augmentation, these data profiles associated with their models, can we automate how, a full pipeline of not just putting together data quality checks, but also when we're building a model, training a model, developing a model, can we automate that feature selection where it's inspecting a data set, looking at, one model versus another, what is the best types of features or transformations we should apply to those data sets or to those pipelines to feed into a model. And so with that, metadata, and if we're, of course, tracking what those ideal features are correlated to those models, we can try and make those predictions. Other examples, of course, being, like automatically adding the noise or transforming with data augmentation, to enhance these models. And so that's kind of like part of the source that, helped lead us down this road of building the data profile library. We want to standardize data profiles, make it seamless to build these profiles as a community to enhance our ML processes overall. So within our open source library, we focused on making like 3 easy commands, which is this, loading the data set, being able to calculate these profiles, of course, and then, whether it's for humans, something that's human digestible, easy to iterate on, for manual creation of, the previous use cases, or it's for, machine interpretation to automate these processes. We wanted to build this library in such a way that would allow us to take both of these pathways. And the important thing is to do this with unknowns about the data. Because if we're trying to gain insights on the data, we shouldn't have to know anything about it from the get-go. And so that's kind of the overall concept in this pipeline within the library, is that, you take this first element, which is just grabbing the data, this dp.data, and this assumption that we don't know anything about the data. So let's automatically read that data. And then from that data set, let's automatically profile that data. We're not going to specify what that data set is besides where it exists. We're just going to point to it. And then we're going to throw that into a profiler to help to automate this process of taking data and profiling it. And it's going to automatically try to identify, whether it's structured or unstructured or graph profiler or some other type of profiler. So that way we can build these automatic pipelines, build these automatic checks, or, automatically build synthetic data. And so ultimately, here's what that same flowchart looks like in code. It's essentially no different. Just simply inputting data into the data class, and it can automatically determine whether it's CSV, Avro, Parquet, JSON, or even point at a URL, pull it down, and read that data set automatically with no input from the user, which is really important. So it's automatically, like for instance, for CSV, it's automatically determining delimiters, header formation, and it's doing that without any input from the user about the structure of that file. And then it seamlessly, again, goes from the data class into the profiling class. And of course, from automatically profiling that data set, you can then generate your report. Like I said, whether it's, human digestible or machine digestible, we're trying to automate these processes. And again, data is dynamic. So profiles should not be static. Profiles should update as data updates. As it comes in through a stream, these profiles should be able to update or to create snapshots and historical patterns of those data sets as it comes in through a stream and be able to make those comparable. Or for instance, with big data, right? We need to be able to split these data sets into multiple components to do our profiles, to parallelize it. to parallelize this profiling process. And so ultimately, within this library, you can update a data set or update a profile with an updated portion of the data set, or you can use the map reduce functionality of profiling smaller components of a data set and then adding them together to reduce that into a single profile that describes the data set as a whole. Data sets need to be able to be transferable, right? So we have like saving and loading of profiles. So you can hold a data set either within an environment to then be used at a later time or to transfer between people. They should be transferable. It should be able to be saved to be reused, especially for automating building these pipelines. And then, of course, we have our profile differences to be able to identify or to compare data sets, identify what's changing between them. And we talked about all of these different situations, right? We talked about the use case for modeling and being able to understand how data sets changing, or what components of a data set might be improving a model. Of course, that's where differences come into play, or manual inspection into a profile comes into play. We talked about building anomaly detectors or drift detectors, as well as we talked about synthetic data generation. So building these profiles, automatically building them, hosting them in a secure environment, whether we're transferring those data profiles out or keeping them within. And then, of course, securing that environment, being able to identify where sensitive data exists. Profiles can come into a number of places, but ultimately standardizing these profiles and being able to automate these profiles is how we can really take advantage of them, enhance and be able to enhance our ML processes.